Okay, I think I'll make a start. We have 65 attendees online. So welcome everyone. My name is Sung and I am the Innovation Project Lead at UK Power Networks. And we are pleased to be hosting the Changing Lanes webinar today, which will cover two flagship innovation projects, Optimise Prime and Charge, both of which are focused on facilitating and accelerating the electrification of the transportation sector, which will ultimately support the UK government's net zero emissions targets. So both project teams have been working closely together since the beginning of our respective projects, and we have agreed that collaboration is key, and we are committed to continuing to share learnings, leverage benefits, and disseminate our knowledge throughout the lifetime of each of the projects. So I'm excited to say that we have several speakers from both project teams today who will be sharing with you some of the exciting developments that have taken place to date. And I would just like to add that during this challenging period in this ongoing battle of COVID-19, that both our projects are still committed to progressing under business as usual circumstances, and we are still committed to delivering all the benefits that we set out to achieve at the beginning. And in addition, we are also committed to bringing you, our stakeholders, the latest updates on our project. So that is why we have organized the webinar today, and we would love to hear your feedback on how you feel it has went. So today, the main topics that we'll be covering is I'll give you a brief introduction of both projects and where the synergies are. And then Optimise Prime team will go through the profile connections offering and the site planning tool. And the next charge team will present to you of the three transport model, the smart charging, the Connect More tool that they're developing, go into more detail through those. And then Geoff will take you through, from S-Pen, will take you through the learning more, how you can join us as well on the projects and how to get involved. And finally, we'll have some Q&A sections at the end. And just to remind everyone that there's a Q&A feature on Zoom, so please type in your questions and as they pop into your head, and then we'll endeavor to answer them during the webinar, or if you can't get to them, we'll respond offline. So Optimise Prime is a 16.4 million innovation project funded project, which is funded through Ofgem's Network Innovation Competition funding mechanism. And it brings together leaders from the field of energy, the distribution network, technology solutions provider, fleet and private hire vehicle operators. And the aim is to help networks plan for and accelerate through this EV revolution. The consortium consists of Hitachi as the project lead, UK Power Networks as the lead DNO partner, SSEN as a partner DNO, and we have Centrica, Royal Mail, and Uber as the trial partners. Optimise Prime is developing and is aiming to demonstrate practical solutions to overcome the technical and commercial barriers for fleet operators of all different types transitioning to electric. And it is the world's largest commercial EV trial, which we're aiming to target up to 3,000 vehicles. So there are three distinct trials as part of this project. So we have Return to Home Fleet, which is led by Centrica's British Gas Fleet. They're looking at a fleet whose drivers, employees, they return home to charge. Then we have second, the Depot Charging Trial, which covers the return to depot fleets and is led by Royal Mail. And finally, we have the Mixed Charging, which covers the private hire vehicle fleet led by Uber, which will have a mix of home charging, hub charging, and en route public charging. So we've identified, based on our analysis and stakeholder engagements, that there are different types of fleets, and we want to accommodate all different types in our project. So next, charge. Charge project is the overall value of the project is 8.5 million, but for off-gem funding, it's a 6.85 million off-gem funded through the same mechanism as Optimise Prime, the network innovation competition funding mechanism, and it brings together expertise from the fields of transport modeling, planning, connection, and charging solution. And the aim is to accelerate the connection of EV public charging infrastructure. And it aims to do this by first to combine transportation planning and network planning to maximize available network capacity. So this is for the first time that it's combining transport planning and network planning. And this is a great example of collaboration between the transportation sector and the energy sector, as two industries are continuing to converge due to the EV revolution. And secondly, it's developing and trialing innovative smart charging solutions for destination and en route charging. And thirdly, developing a connections tool, which is termed Connect More online tool to support mass deployment of EV chargers. So the Charge Project Consortium includes SP Energy Networks, PTV Group, Smart to Grid Solutions, and EA Technology. So this slide shows you, this Venn diagram shows that between the two projects, there are clear distinctions as well as synergies that are generated between the two projects. And it shows that the two projects are complementary in nature, and it will bring a wide range of benefits to the industry. And as we can see on the slide, the charge, it concentrates on public destination, en route, and on-street charge points. It's looking at transport modeling, delivery of the EV connection tool, and it's based on SPManWeb's license area, which is Northwest, North Wales, Cheshire, and Liverpool area. Whereas Optimise Prime, we're looking at commercial fleets and private hire vehicles. So we're looking at the impact those two sectors will have on the network. We're testing flexibility that a return to home and depot fleets can provide to the network. We're developing a site planning tool and a new connection offering called Profile Connection. So those two we'll be covering in more detail later in the presentation. And it's based on UK Power Network and SSEN's distribution license areas, which is mainly in the south central, London, and southeast of England. And as you can see, where the two overlaps in the two projects is in public charging. So from Optimise Prime, Uber trials will be looking at kind of the public charging requirements for their drivers. So there's an overlap there. We're both looking at smart charging solutions, and we're both developing some type of tool that will help customers connect more efficiently. And obviously, with this type of event, we're all about disseminating jointly and in collaboration. So that concludes kind of the introduction of the webinar and the two projects. So please bear in mind that you can again ask questions using the Zoom Q&A function. And with that, I'll just pass over to my colleague Florentine, who will get into the more interesting details. So Florentine, I'll hand over to you.
Thank you, Sung. Are you able to give me control of the slides? Is it? I just requested it, I think. So maybe it's working.
Yes. Yep.
So, okay, I don't think I'm able to actually pass from slide to slide, but I can. Okay, now I think I can. Thank you very much. So hello everyone, my name is Florentine. I'm an innovation engineer at UK Power Networks. I'm now going to talk to you about an alternative type of connection that we are developing and trialing in Optimise Prime called a profile connection. So why do we look at an alternative type of connection? Well, the idea is very simple. if a lot of people start to buy electric vehicles and charge them, then the demand on our electricity network will increase significantly. Today, we expect a lot of electric vehicles to come in the next few years. According to our forecasting, it could be up to 3.6 million by 2030. And we would need to invest in the network to accommodate all of this load if we do it in the traditional way, and that would be expensive for customers. It would also take time to carry out all this reinforcement work. So we're trying to think of new ways in which we can try to avoid or minimize this. The profile connection will make it cheaper and quicker for fleets to electrify. And we are looking at this profile connection solution for depot-based fleets in this project, such as Royal Mail. So let's see how it works. Right. So to introduce the idea of profile connections, I'll first explain what smart charging is. Some of you may already be very familiar with this, especially if you've been working closely with electric vehicles or flexibility services. If we think of a depot, such as a Royal Mail depot, it has an existing load. This existing load includes typical office loads, such as light bulbs, laptop chargers, a fridge and a kettle, for instance. That's what we see here in green. Now, if this depot decides to electrify its fleet and the employees drive vans throughout the day, all come back more or less at the same time at the depot, and at that point they plug in their electric van to be charged, then this creates a peak in electricity demand. And that's what we see here, so on this chart in orange. This EV charging extends beyond the gray line, and that gray line is basically the maximum capacity that the depot can use. So the consumption exceeding the maximum capacity means that the fleet operator has to ask us, as the network operator, for more capacity in order to accommodate their new load. Additional capacity may be available on the network, in which case it's very straightforward, but sometimes there is no more capacity available, which means we have to reinforce the network. We have then to do some work on our network, install a new transformer, pull a bigger cable into the ground to supply the increased load. When we have to carry out this work, it costs money to the customer. So now that we know that, the idea of smart charging really is looking at this chart here and realizing that there is a large white area between 1 a.m. and 3 p.m. Where there is a lot of unused capacity. If we charge the vans over a larger period of time, like on this right side, through the night, for example, and it doesn't mean someone coming out to plug in vans at 10 p.m., midnight, or any time of the night, but simply by adding a bit of automation in the EV chargers, then we can accommodate the EV charging within the existing capacity here. This means, well, no additional capacity required, and therefore no potential additional cost or long time to connect. That's what smart charging is about. Okay. Right, so while smart charging seems like a great idea, it's important to realize that it really refers to the technical concept of shifting the time at which vans are charged. In practice, it means that the EV owner has to first be aware that this can be done, and secondly, be willing to adapt their behavior. The key priority for a company such as Royal Mail is to have their vans ready to leave in the morning to deliver the mail. They don't want to worry about when the vans are charged. And they're happy, if they can adapt a bit their behavior without this having an impact on their operational requirements, if it saves them money and time. So at UK Power Networks, we have a number of projects looking at how we can get customers to gradually adopt this sort of behavior, shifting the time at which they charge their EV. And in Optimise Prime, we focus on commercial fleets and their specific needs in charging electric vehicles to find the right technical and commercial solutions for fleet operators to make the most of this opportunity and to ultimately enable them to transition to EVs cheaply and quickly. Right, so as I said, one of the solutions we're developing in Optimise Prime, which relies on the smart charging idea, is this new connection type, a profile connection. A standard connection gives a maximum load that can be consumed at all times during the day. The profile connection has as a variable maximum load limit depending on the time of the day. It can be up to 48 half-hourly time slots per day. The customers then has to make sure their consumption remains within the limit of their profile, basically by using smart systems. And on our side, as the network operator, we monitor this to make sure that the network remains reliable for all. Okay, so now let's see in which case a fleet can actually benefit from a profile connection. So imagine that you have a depot and your depot has a maximum capacity, this green line. Your consumption in electricity is the black curve, and it exceeds the maximum capacity when your EV charging is unmanaged. You can then optimize the charging schedule of your vans, accommodate it within the maximum capacity in that way. That's simple, and you can continue to operate that way. It's pretty straightforward. Another case is you do the same thing. You have an unmanaged charging that exceeds your maximum capacity, but when you look at charging your EVs in a smart way, you know, it still exceeds your maximum capacity, and in this case, your connection needs an upgrade, as we discussed with the smart charging concept. So then what happens is, okay, on our side, we have to, let me just display all of that first. Right. So here, the key idea of the profile connection, this in red, and the agreement that we saw, is that your depot can consume more electricity than your existing maximum capacity. So at certain times of the days, here, here, and here, for example, as long as you do it at these specific times of the day and consume less at other times when the network is more constrained by the consumption of other customers. So this time. So in fact, you're not consuming less overall, you're just consuming at other times. And the additional idea to the smart charging is that you can go over this maximum limits as long as it's during agreed time windows. So to achieve that, we're here relying on what we call the diversified load profile of customers. What do we mean by this? Well, we all want to go to the supermarket after work in the afternoon. The supermarket has a given capacity, and even more so these days, if you go at the same time as everyone else, you will have to queue to enter and do your shopping. It's the same idea with our network. We have a limited existing capacity, and we can't get customers to queue. So if we want to consume this electricity at the same time as everyone else, then we have to pay for the network reinforcement and deliver the power. The alternative is you adopting this profile connection. You can consume more, as we saw, at some times when the network is not too busy, but at peak time, you lower your consumption, and it makes it cheaper and faster for you to connect, because we have no work to achieve, basically. Right, so we have seen that profile connections can make it cheaper for customers to connect by reducing, deferring, or even avoiding network reinforcements. A point that we have learned, but that has become quite obvious as we develop this connections product, is that a small part of the connection work cannot be avoided with a profile connection. It's still allowing to make big savings, but there may still be a little part of the cost that has to be paid. So in particular, the assets that are required for the sole supply of the depot cannot be avoided. Simply, so I'm talking about a cable that would come from the electric line industry directly to your depot and not serving any other customer. Because then you can imagine that this particular cable cannot benefit from the diversification that I just talked about. So this little element would have to be paid by the customer if there is any need for it. But the wider and much larger costs, which are wider network reinforcement, can be reduced or avoided with a profile connection. So on this note, I'll hand it over to Hugo, who will talk to you about our depot planning model.
Thanks, Florentine. Let me just request control. Okay, good afternoon, everyone. I'm Hugo Seymour. I'm the Trials Design Lead for Optimise Prime at Hitachi. I'm going to give you a brief introduction to the site planning tool that we're developing, which is based on some of the work that we've been doing with Royal Mail to help them plan the electrification of their depot-based fleet. I'll talk a little bit about what the tool will do, how it will benefit depot operators and distribution network operators, and I'll go through an example of how it can support decision-making for depot-based fleets. Okay, so as an overview, the tool will be freely available and web-based, and it's intended to be self-service for depot operators considering switching their fleet to electric vehicles. In terms of inputs, it will take fleet data such as the number and type of vehicles that they have in their fleet, the schedules that they operate and the mileages that the vehicles travel, and it will combine it with depot data such as the electricity usage in the depot for other depot uses aside from vehicle use, and also the energy tariff details for that depot. This will all be fed into the model inside the site planning tool, which will then calculate how the picture changes when electric vehicles are introduced. And then in terms of outputs, it will output the estimated electric vehicle charging schedules and costs, any behind the meter infrastructure required to support it, and it will also provide the overall load profiles for the site. This load profile data will be shared with UKPN's Profile Connections planning tool through a direct interface, which will facilitate the process of that depot then communicating with UK Power Networks to discuss and agree a profile connection agreement. So in terms of objectives, the tool will provide the user with the ability to quickly explore different scenarios for a given depot. For example, they could be able to explore the impact of looking at different types of vehicles or different numbers of electric vehicles in their fleet, or the impact of using things like battery storage together with their electric vehicles. In each case, it will illustrate how the choices affect the grid connection requirements to support that fleet. In terms of benefits, for the fleet manager or depot operator, the tool will help them to understand what technology they might need to acquire and manage to support an electric vehicle fleet. For example, how many new charge points they would need and what control software they'd need to have to control the charge points. They'll be able to see whether their planned fleet's charging requirements can be accommodated within their existing grid connection capacity, as Florentine was explaining earlier, and they'll be able to understand the costs associated with the transition, both in terms of investment costs to deliver their planned fleet, and in addition, the expected ongoing costs to operate the new fleet. The tool will also enable them to explore how different approaches, such as the smart charging and smart charging with profile connection approaches that Florentine was discussing previously, could change the picture in terms of upfront and ongoing costs. For the distribution network operator, the tool will help them with their overall aim to support the electrification of transport by making the process clearer for fleets considering the transition to electric. And it will also raise awareness of the new options, such as those that Florentine mentioned, that could mitigate some of the challenges that DNOs face when considering the electrification of transport. There's also the potential to reduce the administrative burden involved in agreeing a profiled connection in terms of gathering the data about each of the sites for which a profile connection agreement might be considered. Ultimately, it encourages more efficient use of the network by encouraging applicants to consider the wider impacts of the transition to electric vehicles. So finally, I'd like to finish by giving you an illustration of the sort of insight a fleet operator would be able to get when comparing three possible approaches to running an electric vehicle fleet at its depot. So we'll look at unmanaged charging as the first scenario. We'll look at smart charging with a standard connection agreement, secondly, and finally, smart charging with a profile connection agreement. In all cases, the number of EVs at the depot and the number of charge points remains the same across the three scenarios. So if we consider the unmanaged charging case first of all, in this example, we have a depot with a fleet that operates two shifts, an early one that returns to the depot mid-morning and a late one that returns end of the afternoon. All the vehicles are plugged in on their return and they charge at the maximum possible rate until the vehicle battery is full. As you can see from the black line in the chart, this results in two peaks in the total depot maximum load, which coincide with the vehicle return time, so one late morning and one late afternoon. As you can see, these would exceed the existing connection agreement, which is shown as the dashed green line. So the depot operator would then need to request an upgrade to their connection agreement capacity to a higher level as shown by the red line. In terms of costs, in addition to the capital cost for the electric vehicles and the charge points, and potentially for the upgrade to their connection capacity, as explained by Florentine earlier, the peaks in demand in this case also coincide with the most expensive times of day for their electricity tariff, as you can see in the bar chart below, making their operating cost to manage this fleet higher. In the second scenario, we consider the impact of introducing smart charging capability with a standard connection agreement. In this case, the timing and rate of charging is controlled by a software system that ensures that the overall depot electricity consumption is minimized as far as possible across the day, while maintaining the fleet's ability to complete the next day's routes. So by the time when the vehicle is due to leave the depot, the software ensures that it has enough charge in the battery to complete the mileage that's required of that vehicle for that day. As you can see from the black line in this chart, this results in the afternoon peak flattening and shifting later into the night. In this case, as you can see, we're still exceeding the existing connection agreement shown by the dashed green line. So the depot would still need to request an upgrade to their connection agreement capacity, but at a lower level than in the unmanaged charging case, as you can see from the red line here. Cost-wise, the upfront costs may be reduced slightly due to the lower increase in connection capacity required, as Florentine was explaining earlier, and the operating costs will also be lower, as most of the vehicle charging demand, as you can see, is shifted to a time of day when the electricity tariff is lower. Finally, we extend this scenario a bit further by introducing a profile connection agreement as well. In this case, we have a variable capacity limit that means that more of the charging load can be shifted into the night time. So as Florentine was saying earlier, it gives you the flexibility to go beyond your existing connection agreement at certain times of day. So we could see in the night time, we have a higher level, which is then offset by a low level at other times of day. In addition to reducing the operating costs by mainly using the electricity during the night time when the cheaper tariff is in operation, it could also reduce the upfront costs. For example, if the new charging pattern avoided exceeding the capacity of a shared network asset that would have otherwise required reinforcement. So just to conclude, by making the implications of these different choices around charging strategy clear to the depot operator, the site planning tool will enable them to be guided towards the most efficient option, both for them in terms of their upfront and ongoing costs, but also for the distribution network operator and the wider network that, whose assets they're sharing the use of. Thank you.
Hi everyone, I'll just try and take control if that's possible. There we go, hello. Hi everyone, my name's Lawrence Chittock. I'm the project lead from PTV, and I'll give a bit of an introduction to what we're doing in the project. But first up, the Charge project, as Sung has mentioned, is bringing together three complementary methods. And we have other partners in the project on the call who will talk about their elements. Okay, so the three methods, as we call them, or the different aspects of the project that contribute to Charge are a transport model. So as Song was mentioning, the confluence of these two industries is coming together with the electrification of transport, and being able to leverage knowledge from the transport sector is really useful, and it's something that's new and innovative in this project. In a similar way, but with a different focus, we're looking at smart charging trials in the project, and there'll also be an online connections tool to help facilitate the installation of public charging. And as was mentioned earlier, the focus of Charge is to really look at what can be done to facilitate public charging, more for private vehicles. So whereas Optimise Prime is focusing on commercial fleets, we're looking at speeding the transition for private vehicle owners to be able to charge in public locations and on street locations. So as mentioned, I'm Lawrence Chittock, and PTV are leading the build and development of the transport model. I'm going to spend a little bit of time talking about a background to transport modeling, because I expect it's quite new to some of you who may work in the energy sector. I'll show some of the analysis that we can harness from the tool, and then talk a bit about the next steps in the project from our point of view, before passing on to colleagues to talk about their elements. So a transport model is not entirely dissimilar to models that you may have come across before in the electricity system, but essentially it's a digital replica of the transport system that includes the road network, public transport routes, and demand for traffic, so and lots of demographic information that show us where people live, work, and their desire to travel, and we calibrate all of these models with observed traffic counts and movements data. Similar to the electricity sector as well, there are lots of types of models that we can implement to answer different types of questions. One of which is a responsive model. So in the last few years, certainly live data models are becoming more and more important to be able to respond to traffic incidents, perhaps on the road network, and be able to react in a sensible manner. There are operational things we can look at. So how do you optimize a bus service, for instance, to maximize demand on a public transport route, or optimize it that way? And as things like COVID will be affecting the public transport system in the future, how can we potentially run a bus or train timetable so that perhaps social distancing can be maintained is something that we can do in a transport model. We can also look to how to manage travel demand, similar to managing electricity load and pushing demand into off-peak periods. We can also do similar things in transport. And we can also test what-if scenarios. So what if we introduce a new metro line? What effect is this likely to have on how people travel? And what kind of modal shifts can we see from that? Are people moving from their cars if we introduce a new public transport scheme? The focus of what we're doing in the Charge project, however, is really on anticipating the future. So models are primarily forecasting tools, and we're using the transport model in Charge to help anticipate where people travel to and from, and then in the future, as more and more electric vehicles come online, how these vehicles will travel and what their demands for energy will be based on their travel patterns. So the latest update is we have built what's called the current year model. It's built in our software called Visum, which is a strategic modeling software, and the model covers the whole of the SP Manweb area, which is the northwest of England and North Wales. And it represents all travel movements in that area, particularly including car trips, their distances, and the time of day that these trips are carried out. And the sort of analysis that we're really looking at in the Charge project is to know where and when people travel, how far they travel, and from that we will be inferring how much energy demand there's likely to be in various EV futures. At the same time, all of these results can and will be overlaid with the electricity capacity map. So the aim of this is to understand where is there likely to be demand for charging and where is there potentially a shortfall in supply capacity. And then what can we do to help mitigate this in the future? What can we do? What implementation schemes can we put in to help serve the possible future demand? So a little summary of what the model is showing and what it's representing. So we're covering a population wider than the Manweb area to include people that travel in and outside of the area. But typically the model is validated against observed data, so we know that the number of trips represented is accurate, and the spread of where those trips are going to and from is accurate. The power in it comes from being able to analyze the geographic and temporal spread of future EV demand, and I'll show a little bit about that on the next slide. In addition, it can help highlight where additional support for public charging might be required. So alongside the transport model that we've built, we've also developed a set of future EV scenarios, the summary of which you can see on screen now. The purpose of the scenarios is to help us forecast with in light of uncertainty that we know we will see in the future. So we're looking at anticipating EV demand all the way up to 2050. And of course, there's uncertainty in how that might develop. But the idea with these scenarios is to really explore what would happen in a high EV uptake world and what would happen in a lower EV uptake world, and then also looking at how public charging might vary in that. Okay, so finally from me, the next steps of the project are to combine what we have already done, which is the transport model and the future scenarios, to model those scenarios in the model and really pull out the key results of where and when is electricity demand expected across a large geographic area. My colleague Elaine will speak a little bit about the Connect More tool, but these results will be presented and made available through the Connect More tool. So at this point, I'll pass to my colleague Tom from Smarter Grid Solutions.
Good afternoon, everyone. Hello, I'm Tom Rafferty, Senior Project Manager from Smarter Grid Solutions. Smarter Grid Solutions deliver systems which manage distributed energy resources such as wind farms and solar farms and ensure their safe operation with the distribution network. This is a similar concept to the smart trials which Florentine was discussing earlier, where we manage to constraints in the network to ensure that we maximize the available capacity. If we can go to the next slide, please, Lawrence. So our part in this trial is integrating charge point operator systems to the network and managing their impact on the network in a dynamic way in relation to the network constraints. The first part of the trial is in the ManWeb area. We have 3 trial sites defined for the first phase of the trial, and the purpose of the 2 phases of the trials is to explore the specific issues in site delivery in terms of what needs to happen on site, what needs to happen to manage the network, and what do we learn from that. We're enabling flexible connections for the public EV charging infrastructure, and we have 3 sites lined up for the first trial. If we can move on to the next slide, please, Lawrence. Thank you. So we have SGS Labs at Ellesmere Port defined for the first trial. They have some local constraints, and they're going to charge vehicles on site. And we're developing site integration plans for Warrington Station and Warrington Times Square car park. We will be doing the trial design for each of these locations, then integrating the computer systems to manage what happens, what the level of charging is, and then to store that data and share that for future analysis. Thank you. Passing on now to Elaine.
Thanks, Tom. So I'm Elaine Meskey, Senior Consultant and Project Manager from EA Technology side. We have experience in building software tools for distribution network operators, as well as running innovation projects. So today I will talk to you about the Connect More online tool. So on this next slide, you can see some of the things that the Connect More tool will show and do. On the left, there is an example screenshot of a tool which will enable customers to indicate their required connection, stating the size and drawing the location to instantly generate a cost estimate for that connection. Where appropriate, this quote will also include the flexible connection options as trialed by SGS that Tom spoke about. So that's one part of the tool that will build on existing load flow software extended to enable fault level calculations and assessments of interconnected networks, configuration of the networks that's specific to ManWeb, a license area shown on the right there, and also UKPN has interconnected networks as well. The second aspect of the tool on the right is this heat maps. So on here we have the EV demand from the PTV model over different years and scenarios that will be coming soon. And overlaid on that, the coloured spots, the traffic light coloured spots show the network capacity for connection. So the purpose here is to help users identify the sweet spots between charging demand where that is high and also where there's good capacity on the electricity network for the connections. On the next slide, we'll see the list of users that this tool is for. So whereas UKPN's tool is for fleet operators, ours is for public charge points, and therefore we've identified users such as local authorities or charging network operators or leisure destination managers, town councillors who will use our tool, and we've engaged with them on a number of workshops to get to understand their requirements, their pain points, their goals. And from this, we are developing a specification. So we know it's crucial to make it easy to use, so there'll be a step-by-step interface with tutorials to help guide non-technical people through the process and the terminology. And we anticipate that there'll be a number of key benefits in terms of helping the users also to pull together the evidence to support longer-term strategic decisions on where and when to deploy charge points. Our agile development approach means we will continue to engage with stakeholders and users throughout the development process, particularly as and when our beta version goes live next year. I'll hand over now to Geoff, who will talk to you about what's up next.
Hey everyone, my name's Geoff Murphy. I'm the overall project manager for Charge from SP Energy Networks. Just to round up on our little session on the Charge project, hopefully we've given you an initial taste of what we've been up to on the project. The good news is we are expecting to deliver a lot more on the project before the end of the year, including the three smart charging solution trials that Tom mentioned, the high granularity transport heat maps that we've talked about with the transport model, which will highlight where there's going to be where we envisage high demand for public charging infrastructure from 2020 out to 2050 across the ManWeb license area. And as Elaine touched on there, we will mapped out the exact requirements of the end users of the Connect More tool. So a lot is going to be delivered in the rest of the year. So moving on, in terms of the agenda, I'm just going to wrap up on the learning more and getting involved session. So this is obviously just an initial hour-long webinar. It doesn't give both projects probably full justice of what we've been up to. I'm sure many of you would like to know more and be keen to see how you can get involved. So as you can see from the screen right now, we still do have 2 dissemination events planned where we plan to do some shared dissemination, in particular a half-day session at LCV Cenex, as well as the LC&I conference. At present, neither of these events have been cancelled, but we are expecting them to be postponed due to the COVID restrictions. So what we'll do is we'll endeavour to keep you all up to date as and when we have more certainty about these events. But I think this webinar has been going well so far. If you've got any feedback, please send it in. But if the feeling I'm getting at the moment is this has been a success, and would like to probably do more of these over the next coming months, particularly if the restrictions stay in place. In terms of looking for project partners and getting involved, in particular with Optimise Prime, there's an animation there, Lawrence, if you can just click it. I think there's an extra, yeah, sorry. As you can see, Optimise Prime are looking for participants. They're looking for fleet operators, particularly in London and South and South East England. These are home fleet operators and depot fleet operators. So if anyone fits the bill and is keen to get involved, please reach out to the Optimise Prime team on the addresses below. I think the QR code takes you through to the Optimise Prime website also. So hopefully a lot of you are buoyed by what you've seen today and you've heard and keen to get involved, so please reach out. And in particular, those trials are for 2021, so hopefully that fits in with a lot of people's time frames. Similarly to ourselves, we are looking for project partners. As with Optimise Prime, it's predominantly for 2021. And we're looking for anyone that is planning or has existing charge points in the SPM license, SPA ManWeb license area. In particular, we're looking for partners who are willing to adopt flexible smart charging solution based connections with sufficient sort of charge points to challenge the network and provide sort of flexibility. So if there's anyone who fits the bill and is keen to explore those options, please reach out to myself and the rest of the team on the addresses below. We'll be going on a major recruitment drive in the next few weeks via our webpage. So keep an eye out for that, and also all social media channels once the COVID messaging settles down a little bit. So all that's left, you'll be pleased to know, is me to hand over back to Sung for cover off some of the questions that have come in prior to the webinar and during the webinar. I think we've got more than we're probably going to be able to handle, but I'm sure Sung will do a good job of picking the right ones to ask at this time. Over to you, Sung.
Okay. Hope everyone can still hear me. So thank you everyone, the presenters, for going through your respective presentations. So we had questions that were pre-submitted during the registration stage. So we plan to cover several of them today at this time, and I think I've seen quite a few that have come up through the Q&A Zoom. So maybe we can go through a couple of the ones that were pre-submitted, and then also ones that we've got from the live session. So yeah, so maybe one of the first questions that we can answer is, so one of the questions that was pre-submitted was, what do you think the impact will be on EV uptake generally given the current crisis of COVID-19? So James Bracegirdle from Hitachi, who is the program manager, maybe perhaps you can share your thoughts.
Sure, Sung. Good afternoon, everybody. I think we're seeing a sort of a tale of two halves in this year so far. The sales of battery electric vehicles and plug-ins were significantly up year on year to January to March 2019 to 2020. Although overall car sales were down quite significantly. I think we're going to see that continue as a lot of the car manufacturers have shut down their plants. They're only just starting to reopen, so we're going to see a delay in the availability of battery electric vehicles. I think we've also got the problem of people's incomes. A lot of people have been furloughed, and so they won't be purchasing new vehicles. So I think we're going to see a drop in demand there as well. So I know that a lot of the leasing companies are particularly concerned about the return of leasing cars and are looking to put in payment holidays with those as well, because of the knock-on impact of the second-hand car leasing prices and the general second-hand car market. You know, people probably will be choosing to keep cars rather than buy new ones. So I suspect we're going to see a dip in the overall uptake, despite the fact that sales increased in the first quarter of the year.
Okay, thank you, James. Second question, or perhaps we can go to one that was that has come during the presentation session. Let me just choose. So there's one for Hugo. The depot planning tool is on the depot planning tool. When it produces an output, a result, does the cost of chargers and installation costs get included? And if so, how does it do that, given that the costs can vary? Is that something you can answer, Hugo?
Yes, absolutely. Thanks. I think the first thing to say is probably that the tool is still in development. So while we have an idea of where we want to get to, the specifics are still being worked out. But having said that, I think in terms of the cost, the intention is absolutely to include the upfront cost, both to acquire the charge point and to install it. But there'll probably be benchmark costs rather than specific costs for a given site to increase the simplicity of the tool. As I said earlier, the intention of the tool is to enable different scenarios to be explored and to compare between them in terms of planning the grid connection. So the specifics of the cost doesn't matter greatly unless you're varying significantly the number of chargers. So if you're looking, for example, to explore between smart charging and unmanaged charging, if you still need the same number of charge points, and the cost difference between them would be minimal, if anything at all. So hopefully that answers the question.
Okay, thanks, Hugo. I see a comment here from Keith Budden. I hope I pronounced that right. That we are still hoping that LCV will be taking place in September. So that was good. Thank you for that. There's a question for the charge team that's come through from Hywell Lloyd. Does the charge project have stated assumptions regarding balance of charging between home and fuel station and changes in volumes? Is there anyone who can answer that from the charge team? Is there any assumptions that are stated so regarding balance of charging between home and fuel stations? I guess this is based on the personal vehicles.
Yeah, I can take that one, Song. So yes, we're exploring sort of a set of assumptions through the scenarios. There obviously is data from current EV users that show us the split between home and, as you say, fuel station or sort of any other destination or en route charging. But it's not necessarily going to be that way in the future. We may flip to more of a fuel station type of market and situation. So yes, we'll be testing some of those in our scenarios. And one of the drivers for that is, where do people drive to and from? And could infrastructure be met to be placed to help meet their demand rather than the other way around, which is sort of where we're currently at.
Okay, thank you, Lawrence. There's another question that was pre-submitted. Is smart charging part of your current suite of EV solutions? Just from our perspective, UK Power Networks, yes. So we support maximum market freedom. So we promote the market-led approach to smart charging and different price signal mechanisms to incentivize flexibility that can be provided by EV charging. So we have several projects, innovation projects that are running in parallel called Shift and Transpower. So Shift is looking at different types of smart charging products that can be offered. So there are things like time of use, distribution user system charges that is being looked at, flexibility services that can be provided is also being looked at. We have another project called Transpower, which is looking at V2G, vehicle to grid. So it's going a step further where the vehicle can provide actual inject energy back into the network during those times where grid is constrained. And so smart solutions is definitely part of our suite of EV solutions, and it will continue to be going forward. Tom from SGS, do you have anything to add on that, or anybody else?
It's Geoff here from
Geoff,
SP Energy Network. Yeah, I think echoing your comments from SP Energy Network's point of view, yes, we're taking the same market-led approach. If customers are after smart EV, smart charging solutions, we will accommodate that. And predominantly, that is all being pushed through the Charge project. So this is predominantly our flagship project for developing our suite of smart charging solutions. Having said that, it doesn't have to come through Charge. If there's customers out there with the solution and they seek it, we can do that as business as usual as well. So we're keen to work with all customers to facilitate the connection of EVs.
Thank you, Geoff. I think it looks like we'll have to wrap it up there because we've come to the end of our session. But for those questions that we didn't manage to answer, we'll release them. We'll answer them. We'll release them on social media or via email. So please look out online as as we'll get back to you. So we appreciate all the questions that was sent through, both during the pre-registration stage and the during the session today. So thank you very much for taking your time to join. We trust that it has been useful and informative. As Geoff said earlier, if you can provide any feedback about the webinar, that would be really, really great, so it can help us to understand how we can better meet our stakeholders' needs. So I believe the presentation materials will be shared after the webinar, so please also look out for that. So thank you once again, and everyone, please stay safe. Thank you. Bye for now.
Excellent.